Welcome to lecture 30. So, this is the last lecture on pressure measuring instruments. As of now, we have talked about pressure measuring instruments that are useful for measurement of moderate pressure, measurement of low pressures and measurement of very small pressures or high vacuum. So, today we will talk about differential pressure cell, we will talk about certain accessories for pressure measurement, and finally, we will talk about how to select a pressure gauge for our application. So, today's class will conclude our ongoing discussion on pressure measuring instruments. So, this is today's topic. We will talk about differential pressure transmitter, we will talk about some pressure accessories, and we will talk about how to select a pressure measuring instrument for my application. So, let us start our discussion with differential pressure transmitter known as DP cell. What you see is the photograph of a DP cell. So, DP cell is a differential pressure cell. So, it measures delta P or difference between two pressures. So, you will see here that there will be connections for two different pressure sources. A DP cell is used to measure the differential pressure between two input points. It consists of a sensor, a transducer and a transmitter combined in a single device. Now, let us try to understand the working principle of a DP cell. In a DP cell, the diaphragm remains in normal condition when the forces on both sides of it are equal. So, you have diaphragm, in fact capsules made of diaphragms. We have talked about pressure capsules when we talked about measurement of moderate pressures. So, the diaphragm remains in normal condition when the forces on both sides of it are equal. So, these are the two pressure sources which is acting from both sides of the diaphragm. The unequal forces, that means pressure difference, create deformation in the diaphragm. The differential pressure is calculated from the extent of deformation. So, essentially you have a diaphragm mounted in a chamber, and you have two pressure sources which will be applied on from both sides of the diaphragm. If these two pressures are equal, the diaphragm will remain in its normal position, but if they are different, there will be a deformation of the diaphragm. Here we are applying high pressure from this side. So, the diaphragm will deflect in this direction. Typically, this diaphragm will be filled with silicon oil. This will be useful for transmitting the pressure uniformly throughout the diaphragm capsules. So, the diaphragm capsules will be filled with silicon oil, which is useful for transmission of the pressure uniformly. There is a backup plate inside the diaphragm capsules. Now, this diaphragm capsule is attached to a force bar. So, this is the force bar. This is connected to the diaphragm capsule. Now, this is sealed and pivot. So, as the diaphragm capsule deflects in this direction, the force bar also makes a displacement. So, this displacement of this force bar can be read by a displacement transducers. We have talked about several transducers, capacitance type, LVDT type, even pneumatic transducer is also possible, like we can take help of flapper nozzle systems. So, the displacement of this force bar will be considered as a measure of this difference between these two pressures, because the difference between high pressure and low pressure will cause a deflection in this diaphragm, and that deflection will cause a displacement to this force bar. So, I can measure this displacement of this force bar using a pneumatic transducer or an electrical transducer, and accordingly can get an output in the range of 4 to 20 milliampere current if I am using electrical transducer, or I can also get output in the range of 3 to 15 psi pressure if I am making use of a flapper nozzle systems. So, we can have two main types of DP cells, pneumatic DP cell and electrical or electronic DP cell. So, the output of the pneumatic DP cell will be in the range of 3 to 15 psi pressure signal, and the output of the electrical or electronic DP cell will be in the range of 4 to 20 milliampere current signal. So, what you now see is a schematic of a pneumatic DP cell. The diaphragm capsule is held between two flanged castings which form chambers on either side. So, you have the diaphragm capsule. So, these diaphragm capsules creates two chambers, chamber 1, chamber 2. So, these two chambers are connected to two different pressure sources. Let us say this is connected to high pressure source, this is connected to low pressure source. So, the force bar is connected to the diaphragm capsules. So, as the diaphragm deflects, there will be displacement of this force bar. This displacement can be measured by a flapper nozzle assembly. What you see is a flapper nozzle assembly with a relay. We have talked about this and we have seen that the relay increases the amount of air which is helpful in the measurement. So, the output, which is a 3 to 15 psi air signal or 0.2 to 1 bar, is measure of difference between these two pressures. So, this output pressure signal is a measure of difference between these two pressure sources. So, basically all I am doing is the deflection of these diaphragm capsules is causing a displacement in this force bar, and that displacement is being converted to a pressure signal with help of a flapper nozzle system. So, this is briefly the working principle of a pneumatic DP cell. So, the diaphragm capsule is held between two flanged castings which form chambers on either side. These are designated as the high and low pressure sides of the DP cell. Movement of force bar can be sensed by flapper nozzle system and differential pressure can be calculated. If you look at a DP cell, you will see that it is written there high pressure side and low pressure side. So, accordingly you will connect the high pressure source and the low pressure source to the DP cell. So, on the DP cell itself it will be written high pressure source connection and connections for low pressure source. Electrical DP cell. In case of electrical DP cell, the output will be an electrical signal. A capacitance type transducer can be used here. Change in capacitance is used to infer pressure measurement. You know that the capacitance is the capacitor's ability to store electrical charge on its plates, and we are now familiar with this equation, which says the capacitance is directly proportional to the area of the plates, it is directly proportional to the distance or gap between the plates, and the proportionality constant is the permittivity of the dielectric material that exists between the two plates. So, this is the diaphragm static position and this is the deflected diaphragm. You have a static plate here and in between you have this dielectric medium. So, here the distance between the two electrodes change and accordingly the capacitance will change. So, once again you see a schematic of electrical DP cell. You can see two capacitor plates, in between you see a sensing diaphragm, you have insulation and you have oil fields which works as dielectric medium. These are the wires coming out from the two capacitor plates. A sensing metallic diaphragm is placed in between two metal capacitor plates. So, you have two metal capacitor plates and in between a sensing diaphragm is placed. Insulating fluid, which is a non-conducting oil, transfer motion from isolating diaphragms to sensing diaphragms. So, I have isolating diaphragms which will receive the pressure of the fluid and transfer it onto the sensing diaphragm. Difference in pressure will cause the diaphragm to deflect in the direction of least pressure, and this changes the capacitance of the cell, which in turn results in a change in the electrical output signal. So, again it is basically causing the distance d different. So, once again a simpler schematic for that. So, I have high pressure source, low pressure source. So, this is one isolating diaphragm, this is another isolating diaphragm. In between I have two capacitor plates, and within this, between these two capacitor plates I have a sensing diaphragm. Two capacitor plates are fixed and I have this in between sensing diaphragm which can deflect. Here this part is full with a non-conducting oil which will work as dielectric medium. So, this is high pressure source. So, this sensing diaphragm will deflect in this direction. So, as the diaphragm moves from its initial position, the capacitance will be different. So, we will get an electrical signal as output, which is a measure of difference between high pressure and the low pressure. The differential pressure cell is one of the most common methods for measuring level. Let us now look at few application of DP cell transmitter. We will talk about pressure level measurement in detail later. For the time being, let us take a look how a DP cell can be used to measure liquid levels. The differential pressure cell is one of the most common methods of measuring level. You may be interested in measuring level in an open tank or in a closed tank. What you see on the screen is measurement of liquid level in open tank. Low side of the DP cell is left to atmosphere. High side measures the hydrostatic head pressure, which is proportional to the height of the liquid and its density. So, I am interested in measuring this liquid level, and the tank is open to atmosphere. So, atmospheric pressure is acting here. We have the DP cell. The high pressure side of the DP cell is connected to the bottom of the tank. That means, this much of hydrostatic head is being fed to the DP cell from the high pressure side. The low pressure side is left open to atmosphere. So, the output of the DP cell will be the difference between pressure here and the pressure here. This pressure is atmospheric pressure. So, this is related to density of the liquid and the height of the liquid. You know the well known formula P equal to rho g h. So, the output of the DP cell, which may be 4 to 20 milliampere current signal for electrical DP cell, can be taken as a measure of the hydrostatic pressure head, which in turn is related to the height of the liquid, given the information on density of the liquid. So, basically your DP cell is used, to measure the level of the liquid by attaching the DP cell at the bottom of the tank. Then you make use of delta P equal to rho g h formula. You can also use a DP cell to measure the level of the tank which is not open to atmosphere, which is a closed one. So, level of the liquid in a closed tank. So, this is the level of the liquid in the closed tank, and upper part, let us say we have some gas with some pressure. So, here the low side of the DP cell is connected to this gas above the liquid, and the higher side of the pressure is connected to the bottom of the tank. This is obvious choice, because at the bottom of the tank you have this hydrostatic head plus this. So, again the output of the DP cell 4 to 20 milliampere current signal can be used to measure the hydrostatic pressure head. So, low side of the DP cell measures the vapor pressure above the surface, the high side measures the hydrostatic head pressure plus the vapor pressure. So, combining these, I can measure the hydrostatic head, and if I know the density of the liquid, I can measure the liquid level or height of the liquid in the tank. The differential pressure cell can also be used for measurement of fluid flow through a pipe. A fluid is flowing through this pipe. I have put an orifice plate. We will learn more about orifice plate or orifice meter when we talk about measurement of flow. For the time being, let us consider that the orifice plate works as a flow restrictor. So, we have put a flow restriction by putting an orifice plate here. So, there will be pressure drop across this orifice plate. So, the pressure here will be higher than the pressure here, because there will be a pressure drop in the direction of flow. So, I can take a DP cell, attach the high pressure side here and the low pressure side here, and then can measure the pressure drop across the orifice plate and can relate the flow rate with the pressure drop. Because I know the relationship, the flow rate is proportional to the square root of the pressure drop. Similarly, it is also possible to locate the interface using a DP cell. These are two pressure sources which goes to DP cell, higher side, lower side. Let us take a quick look at a simple numerical problem on DP cell. Our electronic pressure transmitter works in an input range of 0 to 50 psi with an output range of 4 to 20 milliampere. If the known current is 12 milliampere, calculate the input pressure. Once again, our electronic pressure transmitter works in an input range of 0 to 50 psi with an output range of 4 to 20 milliampere. If the known current is 12 milliampere, calculate the input pressure. So, basically what is being asked is 0 psi is related to 4 milliampere current, 50 psi is related to 20 milliampere current, then 12 milliampere is what? So, span is the difference between upper range and lower range. So, let us just make use of this. Let us consider corresponding to 12 milliampere current, the pressure in psi is P. So, P minus 0 by 50 minus 0 is 12 minus 4 divided by 20 minus 4, which will give you P equal to 25 psi. So, basically you are asking that if 0 psi corresponds to 4 milliampere current, 50 psi corresponds to 20 milliampere current, and what is implicit here is that the interpolation is linear. So, 12 milliampere current corresponds to what? Psi pressure. One thing which is not directly related to this numerical problem I would like to point out is, see that we are saying that 0 psi pressure is connected to 4 milliampere and 50 psi is related to 20 milliampere. That means, the lower end of the pressure is related to the lower end of the current signal, which I take as 4 milliampere, is 4 to 20 milliampere. So, all the pressures will be mapped between this 4 milliampere at the lower end to 20 milliampere at the higher end. So, why do I take 4 milliampere current signal? Why not 0 as the lower end? This is purposefully done so that 0 output from the electrical devices or the transducer is not coming for a faulty operation. That means, 4 to 20 milliampere output from the transducer is considered as lower end and upper end. I could have, if I take 0 milliampere current output as the lower end, I may not be able to differentiate whether that 0 milliampere current is actually 0 milliampere current or a faulty operation. So, purposefully we have taken a non-zero reference, a non-zero number as lower end. So, it is 4 milliampere as has been chosen as lower end. So, if it is 4 milliampere, I know I am talking about the lower end of the pressure signal. So, if it is 4 milliampere current, I know for sure that it is not a faulty operation. So, that is why we consider 4 to 20 milliampere as the range for current signals for an electrical transducer. Now, let us briefly talk about certain important aspects of pressure gauge installation. The following should be taken into consideration. Distance between sensor and source should be kept to a minimum. Sensors should be connected via valves for ease of replacement. Overrange protection devices should be included at the sensor. To eliminate errors due to trapped gas in sensing liquid pressure, the sensors should be located below the source. To eliminate errors due to trapped liquid in sensing gas pressure, the sensors should be located above the source. So, note these last two points. When the pressure sensor should be located below the source when you are sensing liquid pressure, and the sensors should be located above the source when you are sensing gas pressure. When measuring pressures in corrosive fluids and gauges, an inert medium is necessary between the sensor and the source, or the sensor must be corrosion resistant. So, you should isolate the pressure gauge from the effect of corrosive fluids. So, normally we put an inert medium between these two, or we have to suitably choose the material of construction, so that the sensor is corrosion resistant. The weight of the liquid in the connection line of a liquid pressure sensing device located above or below the source will cause errors in the zero, and a correction must be made by the zero adjustment or otherwise compensated for in measurement systems. Resistance and capacitance can be added to electron circuits to reduce pressure fluctuation and unstable readings. These are common gauge failures: overpressure, mechanical vibration, pulsation, spikes, temperature, corrosion, clogging, mishandling and improper use. So, these are certain most common gauge failures. So, let us take a quick look at some pressure gauge accessories. Shut-off valve. All pressure sensors will require periodic maintenance and calibration. During such period, it is necessary to remove the pressure gauge from process stream without disturbing the process operations. Process operation must go on, and we need to isolate the pressure gauge for maintenance or recalibration. Shut-off valve allows this operation without interrupting the process operations. So, this is how the pressure gauge is mounted. So, you have one valve 2 and valve 3. So, this valve 1, so this is the process stream, this is the process stream. So, by using the valve 1, I can isolate this part. By using the valve 1, I can isolate the process from the pressure sensor. The V2 valve will drain out the trapped process fluid, and the valve V3 can be used to calibrate the instrument by applying external test pressures. So, this is how a shut-off valve can be used for regular or periodic maintenance and recalibration of the pressure gauge without disturbing the normal process operation. You can make use of this valve V1 to separate or isolate the pressure gauge from the process stream. Let us talk about two more pressure gauge accessories, siphons and snubbers. In some applications, it is necessary that I do not allow the process fluid to come in direct contact with the pressure gauge. The temperature of the fluid may be high and may damage the sensor. Process fluid may have solid particles which may plug the sensor connectivity. The process fluid may also be corrosive in nature. Siphons inserted between sensor and process stream may protect the gauge. Pressure gauge snubbers are intended to suppress the effect of pressure pulses and pressure peaks. A diaphragm seal does not allow the fluid to come in direct contact with the pressure gauge. So, here I have the diaphragm seal, also known as chemical seal. So, look at here now, we have a diaphragm. So, this is the process fluid, this is the pressure gauge. Let us say this is the Bourdon tube pressure gauge and this is the capillary. So, this capillary and the entire Bourdon tube is completely filled with a sealing liquid, let us say silicone oil. Now, this diaphragm receives the pressure from the fluid is corrosive. I use suitable material of construction for the diaphragm. So, the diaphragm is corrosion resistant. Diaphragm receives the fluid pressure and then it is transmitted to the Bourdon tube or the pressure gauge through this capillary tube, which is also filled with the sealing liquid. So, now the pressure gauge is being isolated from the effect of process fluid by putting a diaphragm in between. So, diaphragm receives the pressure and it transmits the pressure to the pressure gauge. The pressure gauge may be a Bourdon type, C type or spiral type, or it may be a diaphragm, another diaphragm. So, this way you can isolate the process fluid from coming in direct contact with the pressure gauge. Now, finally, how do I select a pressure gauge for my application? There is no a single point answer to this question. You have to consider various aspects. The first thing that should be considered or that comes in our mind is the range of pressure, the accuracy required and the response time required. So, what is the range of the pressures, what should be the accuracy and what should be the speed of response. Accordingly, we must select a pressure gauge. We also have to take care of environment. Is it corrosive? Is the corrosive fluid is being measured? What should be the material of construction then? What is the size of the gauge or dial? Cost is also another important factor. You may also have any specific requirement for the internet applications. So, there are various factors which will govern the choice of a pressure gauge, but most important ones will be the range of pressure gauge or accuracy required and the response time, and of course, whether corrosive liquid or dirty liquid is being used and the cost. So, these factors will govern the choice of pressure gauge for our application. So, that ends our discussion on pressure measuring instruments. From the next week, we will start talking about temperature measuring instruments.